Interference is one of the basic properties of optical waves. It is largely used in our daily life, but do you know what interference is? Hi, I'm Huiyan Li. I'm a student at the University of Rochester, Institute of Optics. This channel, Wisdom Optics, is all about introducing optics and physics to you in an easy and interesting way. Now, let's go ahead and jump into today's video. Interference occurs when two waves overlap. Like when we hear sound from different locations at the same time, they will overlap and interfere with each other, similar to light waves. Light waves can also overlap and interfere with each other, which is called interference. And there are two types of interference: constructive interference and destructive interference. Take a single wave. It has peaks and troughs. So when the peaks of the wave align with the peaks and the troughs align with the troughs, it is called constructive interference. It occurs when two waves are in phase. So the resulting wave will have larger amplitude than each single wave. But for destructive interference, the peaks align with troughs, so they cancel out each other. Here, these two waves are out of phase. So the resulting wave will have smaller amplitude than each single wave, which is called destructive interference. So the destructive interference works for noise cancellation headphones. The microphones inside can detect the background noise, and the noise can be reproduced in a way that is exactly out of phase with the background. Therefore, the noise can be cancelled out. When two waves overlap, the resulting pattern is called the interference pattern. In the last video, we mentioned Young's double-slit experiment, and the result of the experiment is the interference pattern. So the interference pattern looks like a series of bright and dark spots. The bright spots are the constructive interference when two waves add up, and the dark spots are the destructive interference when two waves cancel out. Now you know what interference is and two types of interference. But how is interference related to your life? Well, it has a lot of applications that you might not even notice. When you play with soap bubbles, have you ever seen the bright rainbow colors on the surface? The coloring is due to interference and the separation of wavelengths, which is known as thin film interference. Interference can also be used in the spectroscopy to find the spectrum of the light source. For the double-slit experiment, the interference pattern depends on the spacing of the slits and also the light source. So if we know the slit spacing and measure the interference pattern, we can know the information of the light source. In this way, we can know the composition of unknown materials, which is often used in biomedical spectroscopy and medical imaging. I hope you were able to learn something new in this video. If you're interested in optics, please click the subscribe button and comment below with topics in optics you'd like to see in the future. If you're interested in optics program at UFR, links in the description. I'm Huiyan, and hopefully we shine light on the way you see the world.